Hi, 6th graders. We're on lesson 6.3, which is rate of change, and it's on page 293 in your textbook. So make sure you find your next open spot in your notebook, and on the very top, label your page correctly. The learning target is identifying rate of change and slope using tables and graphs. So the rate of change is a rate that describes how one quantity changes in relation to another. So this is something you should write down. And then change in y over change in x is another something very important that you should write down. So if we look at this table over here on water level loss, it's comparing the week versus the water loss. So our week is our x and our y is the water loss. So if we take the change in all of our y's, we're going from 1.5 to 3, we're increasing by 1.5. Then we go from 3 to 4.5, and we increase by 1.5, and then the same from 4.5 to 6. So for our weeks, we go from 1 to 2, 2 to 3, 3 to 4, and we're increasing by 1 every time. So the change in y over the change in x is 1.5 over 1, and then we simplify that, so then it's 1.5 centimeters per week. So they're losing 1.5 centimeters every week. Okay, you don't need to write all of these tables down, but I would pick a couple at least to write down so you know how to work with the table given to you. So here we're comparing time and wage. So we can see here we're increasing by 9, and then 9, and then 9. Here again we're increasing by 1, 1, and 1. This is our x, this is our y. So our change in y is 9, our change in x is 1. So this tells us that we made, I'm assuming, $9 per hour. Okay, for the number of cars washed, this is our y and this is our x. So I want you to pause me and figure out the rate of change in your notebook for cars washed, and for this one, time in seconds and distance. And as you can see, my computer is about to die, so I need to take a minute and plug it in. So do those problems. Okay, so I can see that I'm increasing my y's by 40. So $40 every time I'm going up. And then my number of cars are increasing by 5 every time. So now I'm going to take my change in y, which is 40, and then divide it by my change in x, which is 5. So 40 over 5 is 8. So then that tells me, because this is $40 and 5 cars, so it's telling me that we made $8 per car. So every car we washed, we made $8. Okay, and then here we again are going up, well not again, but going up by 6 every time. But over here again we're going up by 1. So then we take our change in y, which is 6, and our change in x, which is 1, and we get 6 meters per second, and this line means per, so you can write it just like that. Make sure you're always using your labels. Okay, if we are given some graphs, we can use the points on a graph to also help us find the rate of change. So because the rate of change, remember, is change in y over change in x, here on this graph I can pick 2 points, and I can basically subtract my y values and my x values. So what I'm going to do is I'm going to take 2 18 and 1 9, and I'm going to subtract. So I'm going to take 18 minus 9, and then I'm going to take 2 minus 1. Okay? Here's my y. Both of my y values, I'm taking the difference, and then both of my x's. So 18 minus 9 is 9. 2 minus 1 is 1. So I'm going to put my answer right over here. So it tells us that because our x was number of shirts and our y was the cost of the cost of each shirt. So it's $9 per shirt. Okay? A couple things to look at is make sure you're subtracting both of your y's on the top and then your x's on the bottom. But also, your points need to coincide with each other. So if I'm taking 18 minus 9 for my y's, then I need to take 2 minus 1 for my x's. Okay, I can't do 18 minus 9 on the top and then do 1 minus 2 on the bottom. They have to go in the same order. All right, distance from lightning streak, so we have miles and seconds. So here I don't have any points labeled, and I have quite a few points right on the grid line, so it's easy for me to tell. But normally what I want to do is just pick 2 points that are really easy for me to tell the points of. So here I see that this is 3:15, so I'm going to take that point, 15, and then 5:25. Okay, so I only need 2 points because right now the graphs and lines that we're using are constant. They have constant rates and they have constant ratios, and they're linear equations. So it's okay to just use the 2 points. So I'm going to take my change in y. So I can see that both of these numbers are bigger. So it's easier to take these points minus this point. It does not matter the order that you go as long as you remember line them up correctly. So 25 minus 15, and then 5 minus 3. So y minus y, x minus x. Okay, so 25 minus 15 is 10. 5 minus 3 is 2. So 10 divided by 2 equals 5. And then I'm going to label it miles per second. Okay, I want you to pause me and figure out the rate of change for this last graph that we have. So if we take 12 and 144 and 672, I'm going to go 144 minus 72 over 12 minus 6. So 144 minus 72 equals 72. 12 minus 6 is 6. 72 over 6 equals 7 inches. And we'll say for height per length, I guess. So for every 7 inches of height, our ramp goes that many inches in length. So 7 inches, because it's inches to inches. So we can do height per length, I guess. So that one, I think I'm confusing myself and I'm confusing you. But our rate of change is 7. So if we look back at these graphs, the rate of change is also the same as slope. So we can see that this line has a slope of 9, and we're going to talk a little bit more about slope as the year goes on. But it's basically telling us how fast or how slow our rate is increasing or decreasing. So that's for all of these, and all of these are increasing because we have positive rate of changes and positive slopes. Okay, so you need to log into NICU and make sure you do the 6-3 NICU quiz. Have a super evening, and I will see you tomorrow.